A turbocharger is a turbine-driven forced induction device that forcing extra air into the combustion chamber to increase an engine's efficiency and power output without increasing engine size. For example, a 2-liter 4-cylinder turbocharged engine can produce same power as a 3-liter V6 naturally aspirated engine. So, in this video, we'll learn about how turbocharger works. Also, we'll discuss pros and cons of turbocharged engines. First, we will see the basic parts of a turbocharger. A turbocharger consists of compressor housing, compressor wheel, turbine housing, connecting shaft, bearings, oil seals, and center housing. The turbine housing is bolted to the engine's exhaust manifold, while the compressor housing connects to the engine's intake. The turbine wheel and compressor wheel are connected by a solid shaft that is supported by bearings inside the center housing. An oil feed line from the engine lubricates the shaft and bearings to reduce friction during the rotation. Also, oil can act as a coolant by drawing heat away from the turbocharger. Now, let's see how does turbocharger work? The turbine housing collects the hot exhaust gases, which flow out from the engine and hits it to the turbine wheel with substantial pressure that rotates turbine wheel up to 2 lakh RPM. Since the turbine wheel and compressor wheel are connected by the same shaft, the compressor wheel also begins to rotate simultaneously. As the compressor will spin, it draws in air from the atmosphere, which gets compressed and converts low pressure air into high pressure air. This compressed air is directed by the compressor housing into the engine's intake manifold through a pipe. But the job's not over yet. The compressed air can get very hot, and that's where an intercooler comes into play. An intercooler is usually installed between the turbocharger's compressor and the engine's intake manifold to cool down the temperature of the compressed air and increase its density. More dense air means more oxygen, which allows the engine to burn more fuel and produce more power at the normal atmospheric pressure. The difference between atmospheric pressure and the amount of air pressure provided by the turbocharger is called boost, and it's measured in pounds per square inch. A typical turbocharger provides about 6 to 8 psi of boost. Since normal atmospheric pressure at sea level is around 14.7 psi, that means you're getting roughly 50% more air into the engine. Therefore, you could expect to get about 50% more power. But, it's not perfectly efficient, so you might get a 30 to 40% increase in power instead. Pros of turbocharged engines: enhanced engine power and torque, improved fuel efficiency, reduced emissions due to efficient combustion. Their compact design saves space and reduces overall vehicle weight. Better performance at high altitudes. Cons of turbocharged engines: turbo lag. Turbo lag is the delay between pressing the accelerator and the turbocharger provides significant boost pressure to the engine. It's normal in turbocharged engines. Turbocharged engines are increased complexity and maintenance costs. High temperatures and rotational speeds can cause wear and tear without proper care. Turbocharged vehicles are costlier to produce. Excessive heat generation requires additional cooling to prevent damage. Turbocharged engines often require high-octane fuel to prevent knocking, which can increase running costs. Thanks for watching. If you have any doubts or questions, drop them in the comment section. Also like, subscribe, and stay tuned for more exciting automotive and mechanical topics.